All right, guys, there's one more concept that I want to introduce to you all before we close out Unit 6 and start reviewing for the test. And it's called the Pythagorean trig identity. So you can probably imagine where this thing is going to come from. But what we're going to start with in this lesson is we're going to begin with our regular old right triangle that we keep drawing inside of this unit circle. We're going to draw it in quadrant 1. We're going to make sure it has a hypotenuse of 1, and it's inside this unit circle such that the point that results from that hypotenuse intersects with the edge of the circle. So I'm going to sketch this triangle. I'm not going to say that it is certainly a 30-60-90 or a 45-45-90 right triangle. I'm just going to say that it is a right triangle and that I do not know this angle theta, but I could assume that it's less than 90 and greater than 0. That I could assume. And I know that I have a point that is right here on the circle that we keep calling the point xy. And that's because if I try to figure out where this point is, I have to go over some distance and up some distance to get there. And since I don't know what that some distance is that I have to go to the right, and I don't know what that distance is that I have to go up, I'll call it x and I'll call it y. And that gives me this point xy, the ambiguous point xy, meaning we're not really sure exactly its location. Okay, so this is just a start. Now, what we're going to do is we're going to recall our findings from lesson 6.3. We've labeled the point xy, but what I want to do is transfer that to our trigonometric notation. So this just goes back to a similar process that we keep undergoing. We know from SOHCAHTOA that sine of theta should be my opposite side over my hypotenuse side. And in this case, if I'm at theta, right, I'll use blue theta. If I'm at theta, my opposite side is this side, which we've dubbed y. And my hypotenuse is this side, which we know to be 1, right, because this hypotenuse is the same as the radius of the circle. So opposite over hypotenuse turns out to be y over 1, which is y. And we came to that conclusion in 6.3, which helped us because now we know as long as we stay within the unit circle, sine of theta is just our y coordinate. And we could do the same thing with cosine of theta. That's equal to my adjacent side over my hypotenuse. Well, in this case, my adjacent side is right here. That's x. My hypotenuse is 1. So this gives us x over 1, or x. So what this allows me to do is to say that I could call this the point xy, or since I've decided x is the same thing as cosine of theta and y is the same thing as sine of theta, I could write those coordinates that way as well, right? Because I know they're the same as long as we stay in this unit circle. So from there, we're going to recall the Pythagorean theorem, which says that if I have a right triangle, then if I take my shortest leg and I square it, and then I add it to my longer leg and I square it, that will be equivalent to the hypotenuse if we square it. So let's take this Pythagorean theorem, and apply that to the triangle we have in front of us. This is a right triangle, so we would be able to use the Pythagorean theorem if we wanted to. In this case, my shorter side maybe we'll say is x. My longer side we'll say is y. Nice thing is I know that my hypotenuse is 1, so this is in our triangle. And we're going to make one more leap here. If, in fact, this is true, that this point could be written like this or like this, which we know to be true from our previous lessons, as long as we're in the unit circle, then, as long as we stay within the unit circle, this must also be true. My x is the same as cosine of theta. So I could say, instead of x squared, I could say cosine of theta squared, because we've decided that those two things are the same. Instead of y, I could say sine of theta. Because we know from dealing with this same right triangle that sine and y end up being the same thing when we discuss coordinates of the points on this unit circle. Equals 1, because 1 squared is 1. And the way that you're more likely to see this written in the future is with the sine function in front, sine squared of theta plus cosine squared of theta equals 1. These two things are exactly the same. But this right here is our Pythagorean trig identity. And it says that if we know our sine angle, and if we know the angle, then sine of that angle squared plus cosine of that same angle squared equals 1 according to the Pythagorean theorem. We've derived it from that Pythagorean theorem. All right, so the practice problems that you guys are going to do in class are related to that same concept, and I'm going to post versions of my work that are similar to the problems that you're going to do in class tomorrow.